So hi guys, so I'll be doing the NeetCode 150, and I guess this is my way of documenting the process and keep myself accountable for that I can actually do it more consistently, because I did it when January was starting, then I did for the first week, then I stopped. So I'm trying to get myself to do it more constantly. So the first question is, given an integer array nums, return true if any value appears more than once in the array, otherwise return false. The example here is that we have an array that is 1 2 and 3 3, and this one would return true because 3 appears more than once. Then on the second example, we have an array that is 1 2 3 and 4. In this case, it will return a boolean false simply because there's no number that appears more than once. So now the author suggests that we're looking for a solution that is going to provide us with the time complexity of O of n, and then the space complexity of O of n. Now you could do that with you can get away with I was thinking, you could get away with maybe using 2 loops, but then I actually came up with a much more simpler solution, and I'm going to illustrate it here. So let's look at this. For example, let's just assume for a second that this rectangle is our array and the second one is an array. This is an example. So if we are to have 1 2 3 4, then we have 1 2 3, then 4, then 3, like that. This array, as given by the example, this one will return false, f for false, this one will return true. So we know that's how we're going to do that. One way that could provide us with the suggested time complexity and space complexity is making use of the data structure called the hash set or a hash map. The hash map only allows for it doesn't allow for duplication. It only allows for one number. What we then need to do here is to say, if we can add these numbers in the hash set, any number that is not added in the hash set is a duplication, so we then return true. Otherwise, if there's no number returned that was not added, then we know that it was a false, because all the numbers did not have a duplicate. So for example, let's just assume for a moment that this is our hash map. We start on the first number here. We will say, is 1 already contained in the hash map? If 1 is not contained in the hash map, we add 1. Is 2 contained in the hash map? If 2 is not contained in the hash map, we add 2 to the hash map. If 3 is not in the hash map already, then we add 3. Is 4 in the hash map? Then we add 4 into the hash map. And then we look at the next number, in this case is 3. Then we say, is 3 already in the hash map? Yes, it's in the hash map. If it's in the hash map, then we can stop the operation and then just return true. Now we'll do the same thing, for example, with this one here. We can also just say, is 1 in the hash map? No, it's not. Then we add it. Is 2 in the hash map? No, it's not. We add 2. Is 3 in the hash map? No, it's not. We add that. Is 4 in the hash map? No, it's not. So it's not. Then we add that. So we have already finished creating the whole array, and we didn't find any number that could be rejected because it's already in the hash map. As a result, we are going to return a false. So that's the approach that we can use. Now, the time complexity is going to be O of n because we have to iterate through the whole array. In the worst case scenario that we don't find the duplication number that we are looking for in the first 2 numbers, or the first numbers really, earlier on, then it simply means that we're going to have the time complexity of O of 1. That is if we find them as early as we start iterating. But if we don't find them as early as we iterating, which means we have to go through the whole array. In that case, the worst case scenario that we have gone through n amount of times, whether the array has 15 items, 20 items, 30 items. So then the count complexity overall we're going to say is O of n. Now, when it comes to the space complexity, because we're going to initialize a hash map, if we had to find the duplication when you're starting, it will be the space complexity of O of 1. But if we don't find that, duplication when you're starting, it simply means that we have to add all items within the array into the hash map. Now that's going to be depending on how many items we have in there. So in this case, that takes us back to O of n. So then that becomes both time and space complexity gives us O of n. Now let's see that in code, how that would look like. I'm using C#. So we would initialize our hash map here. I used to do a lot of Python, so I'll still do a lot of indentation for reading sake. Hash set integer. Now this hash map is going to be taking integers because those are the numbers that are coming. That's the input that we're going to be adding into here. We call this num set is equals to new hash set of integer, something like that. So now we have the hash set. So now we're gonna start iterating through the array and adding each number, and then before we add, we compare. Let's start. We have a for loop. So hi guys, so I'll be doing the NeetCode 150, and I guess this is my way of documenting the process and keep myself accountable that I can actually do it more consistently. Because I did it when January was starting, then I did for the first week, then I stopped. So I'm trying to get myself to do it more constantly. So the first question is, given an integer array nums, return true if any value appears more than once in the array otherwise return false. So now we're iterating through the array. We have to then before we add each item, we have to check to see if that item is already in the hash map. Then say if num set dot contains nums at position n, like that. If it's already contained there, then we return true. Then if it's not contained there, then we add it. Like that. Then when we're done here, ultimately, if we don't break in this conditional statement, we're going to continue to add, and then finally we return false, like that. Let's run it. Yeah, there you go. So as I said, the time complexity is O of n, and the space complexity, as I explained, is O of n. Cheers.